All right, how's everybody doing today? You look much happier than the other day. The other day you all looked kind of muted or something. So, any questions about the project before we go on? Yeah. So you want me to talk about overloading the operator? Okay, we will end up talking about that today. And the magic word is when we start talking about this. So when you hear me start talking about this, which won't make any sense to you now, remind me and I will talk about that. Okay. Any other questions? Okay, so a lot of you are working on the project, which is good, right? Why is it good to work on the project early? Why is it good to work on the project early? You have time to get help, so a lot of people have been getting help, and that's a good thing. And so what I'd like to do is I've noticed that as I am helping people, a lot of people are jumping ahead to the writing code part and not spending a lot of time on the thinking about the algorithm part. Does that make sense? Because it's crazy, the stuff's stressful, and you just want to get your code done, so what do? You just write the code. But if you don't think about your algorithm well, then your code ends up being weird, right? Because now just instead of dealing with variables that are like one solid thing we actually have a handle on, we're dealing with pointers, which are kind of ephemeral and weird, and then objects that don't have a name that you need the pointer to get to, so it just complicates things a little bit, right? Have you noticed this is a little hard to think about sometimes? So what I would like to do is I would like to step through an algorithm first and then do the code, okay? And I would suggest that this would be how you would approach things here. So let's say we had a linked list, okay? And we know it's a linked list because it's head, it has a bunch of nodes that link together. This particular list has 9, 12, -1, and 7 on it. And we had a brand new node up here, which I've called new, which actually I don't think in my code will compile. I didn't check. We might have to change that name to new node because new is a keyword. So I apologize for that. But we have some new node here, okay? And what we want to do is add this node not to the front of the list like we've been doing, but to the end of the list. Okay? Everybody with me on that? So the first thing we need to think about is when our algorithm is done, what do we want this picture to look like? What do you mean there should be a 14 after 7? Can you be more precise? Okay, so we should be able to add 14 and 14 should point to null. You're sort of right. You're sort of right. So what a lot of people have been doing when they're adding things to the list, when they're given an existing node, they create a new node and then copy everything from one node to another. That is not bad, but it's unnecessary, right? It would be like me saying, oh, can you carry this bag full of groceries somewhere? And you would be like, yes, and you take out your own bag and copy everything out of the bag and then pick up your bag and carry it away when I already gave you a perfectly good bag. That's a bad analogy, but I am out of good analogies at this point in the semester. So we don't necessarily have to create a new node. We're already given the new node. Okay, so what do we do to put 14 after 7 if that's what you want to do? Yeah? Okay, the only thing we need to do is to change this pointer right here that's in 7 to point to the thing that has 14. And that will be adding it to the end of the list. Okay? Everybody with me on that? So let's just take a look and see what our goal state is going to look like what we want to have done when we're done. And it's going to look like this. Our end state will be that we have everything the same. It's just we've changed this single pointer that's in the node that contains the value 7 to point at the node that contains the value 14. And now 14 is on the end of the list. Okay? Everybody with me on this? Yes? Okay. So the question is, how do we get from here, where we have this null pointer, to here, where we have the pointer changed to 14? How do we get there? What do we need to do? Yeah? Okay, what do we need a temporary pointer for? Okay, so what we're saying is right now, when we have these two nodes, how do we access them? Like, how do we get to node 14? Yeah. Nope, node 14 right here. Pardon? Which one? Yep, the one we're calling new, which is going to turn out to be a bad name. Here, let's call this new node. Because I just realized that when I go to code this, I'm going to have problems. In fact, I'm going to change it up here too really fast. Okay, so we have this pointer that we're calling new node, and we can get to the node that has 14 in it just by dereferencing that pointer and following it. Everybody on board with that? How do we get to the node that has a 7 in it? How do we get to node 7? No, just literally, don't tell me the algorithm. How do we get to node 7? What do we have to do to get to node 7? We have to dereference the pointer that's from -1, right? How do we get to -1? Dereference the pointer from the node that contains 12. How do we get to the node that contains 12? Dereference the pointer from the node that contains 9. How do we get to the node that contains 9? So we can only start dealing with things here if we have a pointer to it, right? And when we start, we can really only start dealing with things from nodes that we have, from pointers that have a name, okay? So we have our choice. To get to node 7, we can either start from new node, but that won't get there, or we can start from head, and from head, we can follow all the way down until we get to that. Okay. Once we get to this node, though, we need some way to access this, right? We need some way to access it. So what do we need? No, that's your cue. What? No, what do we need to be able to access this node? Easily, yes. Okay, we can have a function. What we really need is we really need to have a pointer to this node numbered 7, right? In order to be able to access this, we need to have a pointer to this node that we can refer to by name, okay? So you wanted to jump ahead to algorithm. What's our algorithm going to be then? Okay, so let's not do any coding yet. Let's just talk about things. So what we need to reach this node down here, the node that has 7 in it, right? We need to have a pointer. Now the only thing we can do with our temp pointer is make it equal to something that we already have a name for, right? So we can start by making it equal to head. Then what do we need to do? Advance the pointer and traverse the list. So we look at head, we have a pointer temp, it points to head, and we say, oh, we know this isn't the end of the list. How do we know it's not the end of the list? Because the node we're pointing at doesn't contain a null pointer. So what do we do with the temp pointer? We move it on to the next thing. Okay, we're now pointing at node 12. Is that the end of the list? How do we know it's not the end of the list? Because it doesn't have a null pointer, okay? So now we move on to this node. What's at this node? Is this the end of the list? Why not? It doesn't have a null pointer. We move on to this node with a 7 in it. Is this the end of the list? Yes, it is. How do we know? Because it has a null pointer. Everybody with me so far, algorithmically? All right, we'll write the code for this next. So at the end of this loop, we end up in this situation, right? We have a pointer to the thing that needs to change. We have the thing itself that needs to change. And we have not moved the head pointer. Why haven't we moved the head pointer? because bad things will happen. Lose everything. Everybody with me? Is this helpful so far? Okay. All right, so now we have to change the pointer. How do we change the pointer? We say temp, go to this node, and when you get there, change this pointer to what? To point at the thing that new nodes are. So in the end, we will end up looking like this, right? We make the change and we're done. And now everything is in this state, right? Head points at this, 7 now points at 14, new is pointing at the end of the list. Everything's happy. That is our algorithm. How to repeat what? Yep. Change. So what we do is now at the end of this, after we've looked through to find the node that has null at the end, we use the temp pointer and say, hey temp, go to the node that you're pointing at, which we know is the one that has the null pointer in it. And when you get there, in fact, change that null pointer to, instead of pointing to null, to point to what new node is pointing at. So we set it equal to new node, and then we pop over here, and we have changed this pointer temp. We say temp, go to this object, and point at the same thing that new node pointer is pointing at. Okay? And then it's added to the end of the list. Everybody good with this, algorithmically? Yep. Temp is sitting there pointing at 7. How many pointers can you have pointed at any individual thing? As many as you want. Yep, absolutely. So it doesn't hurt to have extra pointers pointing at things, generally. Yep. Uh-huh. Yep. This is the algorithm for adding things to the end of the list. Okay? Everybody with me on that? Okay. Now we're going to go through and actually code this again. It's going to be a little duplicative of what we've done before, but I just want you to see the example one more time. Okay? So here we are. I have changed things up a little bit. Okay? I have changed things up. In this example, we no longer have the linked list class. All right? We no longer have the linked list class. It doesn't matter that much. Linked lists is where you will implement this stuff. But what I wanted to be able to do for this example is just do stuff directly from main so that we could mess around with the pointers more easily. Okay? So things are going to look slightly different. Instead of the add element being part of the linked list class, it is its own function. Because it's its own function, you have to say what the head of the list you're adding to is. In the linked list class, that's a private data member, so that parameter is not there. Everybody okay with that? Yes, I knew some people were not good with that. I was hoping someone would speak up. So what I've done here is, remember in the last example, we were working with the linked list class, and the linked list class is the thing that had the head of the list. I've taken that head out, and I've just put it inside main instead. We're not working inside the linked list class. The reason we're not doing that is because I want to be able to flip the pointers around from main more easily. Does that make sense? To show you stuff. But in order to help things along, I have created the equivalent functions instead of methods, because they are not part of a class, for adding things to the head of the list and for printing the list so we can see what's on there. In these cases, they have a parameter. And they need a parameter because when it was part of the linked list class, the head was actually a private data member. Because they are functions, we don't have the private data member, and we have to explicitly say, hey, you're operating on this particular linked list. Okay? How many people did I lose with that? I agonized over this example this morning, and I was trying to do it inside the linked list class, and it just wasn't working, and I knew I was going to confuse you, but I had my choice of ways to confuse you, and I thought this would be better. Clearly it's not. Okay, so let me just draw a quick picture on the board. Here's what we're used to doing, right? We have a linked list class, and then main creates one of these things, and then linked list handles all the linked list things, right? That's what we have been doing. What we're doing now is we have main, and inside main I have a pointer, and we're doing all the stuff to the linked list just inside main without the linked list class. We've taken that away. The operations are exactly the same. The only difference is linked list had methods that referred to the head of the list. In main, we have functions that actually refer to a variable. And because they're functions, you actually have to have the parameter in there where you didn't before. If you want to use these functions in linked list, we've already actually written all these. You don't have to pass the head as a parameter because it's already part of the linked list class. So it's slightly different. Does that help? Yeah? Uh-huh. Yeah, I didn't put function prototypes in there. And I did that just so I could write the main code in a way you could see it. So you can also, without function prototypes, just put the functions ahead of time, which is what we've been doing for classes for the most part. All right, everybody sort of with me? Does that help a little bit? Yes, sir. When it relates to the project, we'll use the class method. So what I'm going to do is I'm going to do this here, and then we'll go back and do it over again in the linked list class so you can see it inside the class as well. I just wanted to be able to, it's just working through the class, it's hard to do the pointer manipulations from main. So does that sort of make sense? So, okay. So here we are, we're working in main. Let's just make sure that, let's just make sure this compiles. Sorry, I realized I had the wrong thing in new there. Okay, it compiles. So here's our main right now. We start off with a list, a node star, a pointer to a node, head, which is equal to null. It's empty. We add the elements 7, -1, 12, and 9. And then we print the list. And then we create the new node and make it 14. So if I print the list here, if I run this, you'll see we have the list, 9, 12, -1, and 7. And this should look pretty familiar, right? 9, 12, -1, and 7, and we have new node 14. Okay? So right now the code has set everything up to do exactly what we're talking about. Everybody with me? Yeah? We are going to add this new node to the back of the list. Yep. They are added the correct way. So when we print the list, it'll print out 9, 12, -1, and 7. And here we print it out 9, 12, -1, and 7. So these things have been put on the front of the list. But we're going to add 14 to the end of the list. Yep. Head is, the code is created exactly what this diagram shows right here. Head points to 9, 9 points to 12, 12 points to 1, 1 -1, 1 -1 points to 7, and we have a new node 14. Okay? Yes? Good? No? Bad? Silence means good, I guess? You all owe me $20? Someday I'm going to get you to agree to that, and then I'll, I don't know, buy a tiny fraction of a Bitcoin or something. Okay. If I can still afford it. Okay, so, so here we go. We're going to do our algorithm. We already have everything like this. We want to get here. So what was the first step that we talked about doing? Creating a temp. And where did it point initially? Point head. So how do we do that? Node star, which is a pointer to a node named temp. And do we going to initialize this to anything? To what? You don't have to do null. You can just do to head directly. You don't have to do null and then head on the next line. It's the equivalent. Okay. So we can just say temp equals head. So here we are. We've done exactly this. We were in this situation after this line of code. Temp now points to head. Head is a pointer, so temp points to the same thing that head points to. Yes? Thank you. Okay. So now what do? Now we have a thing here. We need to, anytime temp is not pointing to something that has null in it, move it along to the next node. Okay? We need to traverse the list. How do we traverse the list? With a while loop, right? Exactly. What does that while loop look like? Nope. Nope. So what we want to do is we want to keep moving temp, not until temp is null, because then temp won't be pointing at anything useful. We want to move temp until it points at a node that has a null pointer in it. Exactly. So what we want to do is we want to say, while temp arrow get next node is not equal to null. And what do we do with temp in that case? Right? So what we're saying is, if this thing is not pointing at a node that has a null pointer, what do we want to do? We want to copy the value here in this pointer, right there, to temp. So temp will point at the same thing. So if I can find my code, where did I put my code? There we go. So we can just say temp temp equals temp. And if you think typing is funny, I have accidentally typed horrible obscenities in this class. I've managed not to do that so far this semester. So I'm going to curse myself now because I have 2.5 classes to go. But. Okay. So this is that loop. And this loop is the same one we talked about in last class, where you traverse the list until you get to the node at the end. Okay? So we say is temp get next node is not equal null, set temp equal to temp get next node. So if we step through this, temp, follow temp, is the next node in here null? It's not. It points at something. So what do we do with temp? We set it to point at the same thing the pointer in the node is pointing at. We check again. Is temp pointing at a node that has null in it? Yes or no? So what do we do with temp? We move it to point at the same thing the pointer in the node is pointing at. Is temp pointing at a node that has null in it? So what do we do with temp? We move it to point at the next thing, the same thing this pointer is. Temp pointing at a node that has a null node in it? So what do? We stop the while loop. Okay? We are now pointing where we want to point at. Now we have to change the pointer. We want temp to point at the node, and then in the node, we want the pointer in the node to point at new node. So how do we do that? Yep. So we need to change it. We go temp, because that's how we access this. We now have something with a name that we can access this node. So we'd say temp. Why is it jumping all around every time I switch back and forth? Temp arrow set next node. And what are we sending it to? 14 is the value of the node that's in there, right? But we're setting it to new node. We want this pointer right here to point at the same thing new node does, so we just say new node. All right, everyone with me? We should be done. How can we check if we're done or not? We can print the list. Let's print the list again. Because here's what happens. Temp is pointing at this node. So when you say temp, in order to get to the node, you have to do the arrow, right? So it's temp arrow. And then here, this is an object. And the way that you access the pointer in the object is to use the set next node method. That's fine. All right, so let's print this, and let's run this and see if that worked. How many of you think it's going to work? All right, 14 is now at the end of the list. Okay. Everybody with me on that? Does that sort of help think about how you could do algorithms for these, right? Before you write your code, draw some pictures of like what you expect things to look like and where you expect it to go. This will also help you when it comes time and I give you some completely bizarre, insane pointer code that you have to draw the structures for. All right, that will give you practice for that. If you think I don't do this, you're absolutely wrong. Like anytime, like this kind of stuff now I've been doing for 30 years, right? So this kind of stuff I can do. But more advanced pointers, I absolutely sit down and I draw pictures to make sure that I can mentally understand what's going on. Okay? It's fine, it's appropriate. You should absolutely do that. Okay. All right, any questions on this? This is sort of a repeat of what we did last time where we found the, so, all right, 1 minute break, no more, stretch in place, and then we'll add this to the linked list class, okay? Your choice, man. Your choice. Some compilers won't let it compile without it. So, but it's the polite thing to do. All right, so stepping back to where we were before, this is when we were working on the linked list class. We are now back to working on the linked list, which is slightly different, okay? And I would like to add to our linked list class a method called add_to_end. And it's going to take a node pointer as an argument. Okay. All right. Actually, let's do add and let's take an int. Yeah. So now what's going to happen is the head of the list is going to be a private data member. It's not really going to make much of a difference. Okay. It's only going to make a difference in what we need. So now we're saying before we had add element, now we're writing something called add_to_end. Now remember last time in our linked list thing, we actually wrote something called find last that will tell us where the last thing on the list is. Right? Yep. Because what we're doing is we're going through the entire list, and if we don't find what we're looking for, we're going to return null. If we do find what we're looking for, and here is exactly the same line of code we had before, if temp is equal to null, we're returning temp right away. So we will actually return the right thing. It's just that this method has to take into account the possibility of not finding what you're looking for, because it may not be on there. Okay. Even though it will be in all our examples. Everybody with me? Do you remember we did this last time? This is a method that will tell us where the last thing on the list is. Okay, so now, sorry, bring back this little thing because I remember what. All right, so now here's what we're writing. We're writing void linked list, voif. I'm going to type something horrible now that which makes me nervous about my typing, which of course. Okay. All right, so we're going to add something to the end, and we're given a value. So what's the first thing we have to do before we can add a node to the end? Create the node. So we can say is, and this is going to look pretty familiar, node star new node equals what? New node. And then we can set the value. So we create the new node first, right? All right. Now what do we need to do? Yes, sir. Find the end of the list. How do we find the end of the list? We can use the same while loop, but you know what we've done? We actually wrote a method before to do that for us because it's something we might want to do commonly. And it's easier for us to reason about things if we can just write something once and test it and then use that method instead of writing the loop over and over. So now all we really need to do is we can say temp equals find last. Great. So temp now will point at the last node on the list. Everybody with me? Yep. We wrote this method last time called find last. That does what we wanted before. And what it does is it gives us a pointer that points to the last thing on the list. We wrote that as a method so that we could just call it in multiple places. No, actually here I'd have to declare it though, node star, there we go. Because temp, I'm sorry, I should have declared it. So I'm declaring temp. This temp only exists inside this method. It is not related to the temp up here because of scope rules. But yes, I do have to declare that. So I can say node temp equals find last. You do have to initialize your pointers. You don't always have to initialize them to null. If you want to initialize them to head or if you want to initialize them to something else, you can. But you have to initialize them. It's really important. Otherwise, bad things happen. Okay? So temp is find last. Great. So after this line of code, now we have a pointer to the last thing. What do we do? Okay. Temp arrow set next node and then new node. Looks great, right? We all done? So here's what I'm going to do. I'm going to do this a little bit differently. What we're going to do now is we're going to use our new method. We're going to say list dot add to end. And what number do you want to add to the end? 20? I didn't hear what you said, but we'll just use 20. Okay, so we have a list. We're going to add thing to the list and print it. Look good? Should we compile this and see if it works? Great, it compiled, it must be fine. So we'll just run it now and we will see that we're adding things to the end of the list and printing things, right? A lot of you look really suspicious. Yes, sir. Yeah, I think we did, didn't we? Right here, when we do add to end, we create the value, and this that adds stuff to the end. So in add to end, we set the data. So add to end, we just tell the value we want. All right, everybody confident this is going to run? Why not? What? Because you can sense a trap from me right now, and you know something's going to run. Let's watch what happens. Segmentation fault. Why do we get segmentation faults? Yep. All right, so here's what happened. We did temp set next node, but since the list was empty, since there was nothing on the list, what was temp? It was null. Because what we said is hey, find the end of the list, and then go to the node on the end of the list and change the thing there. But the list was empty. So was there even a node on the end of the list? Everybody understand what happened? Because it was the first thing we were putting on the list. There was no node for us to change. So our algorithm's a little bit wrong. So what do we need to do if temp is null? Yep, if temp is null, then all we have to do is we say head equals new node. That's it, because it's going to be the first one on there. Otherwise, since we know that there will be at least one node on there because temp wasn't null, go ahead and set the last node there. Okay. So we just had to take care of a case where there was no node on there to take care of things. And if we compile this and we run it, we get 20, which is perfect. And if we want to add some other stuff to the end, any favorite numbers? 47, I heard you say, and 13. There you go, just what you wanted. And now when we print these out and we compile it and print it, they will be in the order they were put in instead of reverse order. Okay. Yep. Mm-hmm. In relation to the project, the values for this will be like the subject ID and group. And then eventually the baby when you put the baby in later. Yep. In your project, I don't care how you add it. I really don't. I just want you to understand it can be done both ways, and this is a good way for us to think about pointers one more time, which we need to do. Let me tell you, like you all probably think because I'm a professor and I'm standing here talking to you, I'm some sort of freaking genius or something. This stuff's hard, right? Like it took me a long time to get this. I did not get it in my first computer science class. I don't expect all of you to get it, but I want you to start working on it so that as you get more and more proficient at it, you will learn. Okay? Does that make sense? So, yep. Because we were adding things to the list, but instead of adding them to the front of the list and pushing things along, we are adding everything to the end of the list. So printing it. Yep. Uh-huh. So the question was, can I illustrate with a drawing why we got the segmentation fault? Okay, so let me create a new layer. Hang on a second here. Is the drawing kind of working better now that I pre-draw things? You got to diagram this stuff. The only problem is I also want it to show up in the video. So, okay. So here's what we had. We had okay. So here's what we had when we were originally adding things. We had a situation like this. We had the head pointer that was just null. And then what we did is we copied this and we said, oh, temp will be equal to head, right? Because temp, when it tries to find the last thing on the list, will say null if the list is null, right? So we had this. And then what we tried to do is we tried to do this. We tried to do temp arrow set next node, right? And the problem is that when you do the arrow, it says, okay, go to the end of this pointer, and when you get there, do something on the object that's there. What object was there? Nothing, exactly. So most of the time when you get a segmentation fault, it's going to be because you're trying to dereference a null pointer. All right, does that help? Thank you for asking, I appreciate that. All right, any other questions about this? Yes, sir. Okay, so your question is, we have a linked list. Wouldn't it be handy if maybe we kept some other pointers to things around? So it's possible in some, No, you don't mean to go down a rabbit hole, but you're touching on something important. So what I'm teaching you right now is like ABC, right? Like literally like ABC. I'm teaching you the alphabet. And you're asking me what words can you make with the alphabet? And this is like I'm teaching you cat, or like the most basic word, right? And so how do you assemble these things and interesting things into, dare I say, no, I will anyway, the literature of computer science? We'll talk about that, but what you really get to is you get to that in data structures. Like, how do you store and represent data inside the computer? This is just introducing you to the most basic way of doing it. Okay. All right. Who's happy? Wow, much better than Monday. Who's unhappy? Why? Why are you unhappy? Okay. Yep. Okay, so here we're creating a new node. And the constructor that we have so far, when we build a new node, what is the data inside that node? Like when we build a new node with this new node thing, what data is in there? It's 0, because we haven't built another constructor. We're going to change that actually right after we take a brief break, because it sucks doing it this way. And so once we create this node, when we create the node, by default it has 0 in it. So then we have to put the regular value in. We're going to change that. All right. One minute break right now. Stand up, stretch. All right, welcome back. So I want to show you one other thing. And actually, this came up earlier in a question, so we'll just go ahead and answer your question. Sometimes we want to be able to print things out. So what we're going to do is we're going to write a friend function that helps output a node. Does that sound like a good idea? So first thing we have to do is we say friend ostream and operator, and then what goes in here? Ostream and out, and then node n. All right, is that right? Yes, no? Does that look right to everybody? Okay, and then we can go down here and we can declare it down here. Oops. Hate when that happens. Okay. All right, so we say this. Okay, so now we're going to actually declare this here. And we will say out angle data. And that's pretty much all we have to do, and return out, right? Yes, sir. Friends let friends see their private parts. So we're going to actually, and this should be n.data. What this is going to do is it's going to say when we do output, get the object n and just output the data directly. And because it's a friend function, it can look at the private data. Okay. Uh-oh. Yeah, did I make a mistake? What? Yes, friend is a keyword. Absolutely. Yep. Doesn't it? Oh, no. Oh, I don't have my notes here. And yeah, okay. Much better. Thank you. Okay. Yep. Yeah. I think so. Did I name them wrong? Yeah, I don't even think you have to put the parameters in here. I just do it. Okay, I'm going to be honest at you. At this point in the semester, I get sloppy in my coding. Like earlier on, I'm like trying really hard to make things neat in the way you should. And then towards the end, I'm trying to get more towards concepts, and so I get sloppy in the details. So I'm being sloppy. I apologize. Okay, so we compiled that. All right, so now we can do a couple of things. If we have a node, we can just print it out, right? So if we wanted, we could be like node star new node equals new node. And you know what? We'll get to that in a second. And then we say new node set data to 12. And then we can do this, cout new node. Right? Because we define the friend function. Good? Yeah. Well, this is what we're doing, right? I have an address. I'm calling it new node. So this is an address. So let's see what happens when we compile it. Let's see what happens when we run it. Oh my God. Uh-oh. Well, look what happened is I accidentally printed out the address. So, did you know that was going to happen? Okay. I made that mistake on purpose because I'm trying to point out that you need to think very carefully about what thing you're working with, right? And here, new node is not a node. What is it? It's an address. When we ran this, and I'll run it again so we can see more clearly, when it prints out the address. I wonder why I didn't put my inline in there. Much better. So it printed out the address, right? So if you see that while you're doing stuff, if you start putting in debugging statements to print stuff out and you're getting addresses, then you probably need to dereference something. Okay. So we'll put a star in front of it, and there we go. And now we print it out, it prints out 12. So we've done the friend function for it, okay? But I want to show you one more thing. So the question was, when we do report, how do we do it, right? So say we want to make a little method here for our node that is report. And what report is going to do is report is going to output what's inside the node, right? How do we output what's inside the node? Well, okay, so here's the deal. We don't need to create a node because this is part of the node class. Oops, see? Just like it said, node star, node colon colon. It's part of the node class. So report is going to print out the node. The problem is like, what do we see out right here? How do we find this node to see out it when we're already inside the node? So everybody sort of follow me on this, right? When you call down here in order to print things, we dereferenced this new node and we were able to use cout. Everybody understood that? We had a pointer to a new node, we set the data, we dereferenced the pointer, dereferenced the address to print things out, right? Now, if we want to do something like node.report instead, which is what you're doing in the project, then this report method to use cout has to work similarly. Yes, absolutely. So let's look at what we did here. Node star, what is that? It's the address of what? And what's its name? And what is it equal to? A node that exists at some address. What address does that node exist at? We don't know, but we don't care, because if we wanted to find it, we can just look inside here. This one says, now that we have this nameless node that we have a pointer to, go to that node and put some data inside of it, right? Everybody with me on that? And then we say, output not the pointer, but dereference the pointer, and when you get to the node at the far end, output it, using that friend function that we just wrote. Everybody good on that? Okay. So the question now is, we want to write something, a method called node report that lives in the node class. Okay? Everybody with me on that? Just like we have to do for the projects. Did I lose you all right in there in that step somewhere? How many of y'all are with me? Yes. Okay. So now what we're going to do, so you understood this part, right? Everybody with me here? How many of y'all are with me right here? Show of hands. Who is with me? Who's against me? You're both with me and against me. I feel like I'm making progress. Okay. Now what we want to do is, instead of using cout, we want to write a method for the node that is called report. And report will print out the contents of the node. Yes, 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 it should be. Thank you. Is that the confusion? Does that help? You're still confused. Okay. So everybody's with me on this one, right? Okay. Yep.
So just because like, you have the friend that included, you can just see out, like it just knows to.
Yep. Yep. It's magic. You can just, it'll still be a little magic to you at the end of the semester. That's okay. Yeah, you want to see what happens if we take friend out? It says, hey, look, data is a private member of node. You can't look at private members. No looking at private members unless, what? That's right, because what do friends do? Friends let friends see their private parts. Friend lets friend see its private parts. So, okay. So when you have friend there, you can actually see that you don't get this 160. Oh, I know what I'm doing. Sorry. Node error report. And now I'm missing a bracket somewhere. Oh no. Oh, that's why. Thank you. That's why, because we left that hanging right there. Okay. All right, so I'm going to split this in two. Here is where we're writing the report for the node. Okay, everybody see that? Down here is the example where we did output before. Okay. Now, in order to output a node without an address, we had to dereference that address, right? In report, if we want to output something, we have to dereference that address. But we're inside the node. Does the node know its own address to dereference? No, the self-referential means it points to a different node. But my question is, does the node know its own address? Yes. And it's perfectly natural that you would answer no, because I have not told you how to do it. The way that you get the address of whatever object is in is just using the this keyword. When you type this is a pointer to the object that is currently doing stuff. I know, it's totally baffling, right? So if I wanted to draw the node before, here's what we had. So before, here's what we had. Oh, someday. So here's what we had before, right? We had a node and it had some data in here, and down here it had some address of another node, right? What I'm telling you is something that I have been concealing from you, a secret that I've been keeping from you, a lie I have been telling you, and I'm coming clean. Every node, every object also has its own address. So this is a pointer to another node, but every single object has hidden inside of it a pointer named this. And the this pointer, whereas the other node, the pointer for another node was something that like pointed out there. Sorry, one sec here. Right, if this was a it's like the infinite line. Stop connecting. Okay, if this was a pointer that pointed off somewhere, the this pointer, where does the this pointer point to? Yeah, back to itself. All right, does that sort of help? So any object can get its own address by using this. So in report, all right, everybody kind of get what we're doing there? It's kind of insane, right? But it turns out that it's helpful for an object to know its own address sometimes. Kind of like my analogy is going to be absolutely horrible here, kind of like assume that you didn't have a name, okay? And you were at home and your house was on fire and you needed the fire department to come. Would it be better to say, hey, the person at the head of the street can tell you the house next to you will tell you a house next to you will tell you a house next to you, and eventually you'll get to my house, maybe even before it burns down? Or would it be more helpful for you to be able to say, hey, here's my address, please come save me right now? I know, I'm sorry. I do my best with analogies, so. Well, Dean knows his own address, but Dean knows the other person's address, and the other person also knows their own address. Yes? It knows its address. It has an address, and it's the address of what that node is. Okay? Okay. Everybody sort of know this? Ever see what's going on here? So here's what we can do. With this new node report method, which we lost right here, we can just say cout star this. And what will happen is it will dereference the pointer to itself, and it is then able to use this overloaded operator. Because it's part of node, if you dereference a pointer to a node, what do you get? a node. If you dereference the pointer to a node, you get a. If you dereference the pointer to an int, you get a. If you dereference the pointer to a pointer, you get. I'm just giving you hints of the cruelty that is yet to come. Okay. All right. So this is what you can do inside the report to answer your question from earlier. Okay? You can just dereference the pointer, and if you have defined the operator, it will work correctly. Let's actually make sure that works correctly. Yep. See how it turns purple on my editor? It is a keyword. This is a keyword. And it means a pointer to the object that is currently has code running in it. Okay. All right, you're not going to use this very much. This is probably the only place it'll show up in this class. And by the way, as a joke, I have a new computer. Guess what I named my new computer? This. My new computer is named this. I thought it was funny. So okay. All right, so that is the this pointer. Okay. Yes?
So you have to call the report method on a node object, right? And then that object is what the this refers to.
Yes, it refers to itself. So. Anybody ever watch the TV show Scrubs? I can't remember the actual joke, but there's a guy who was like, which guy is the happiest guy in the world? This guy, right? He was pointing at himself. All right, that failed. Moving on. Any questions about that? Right? You can talk about yourself in the third person. Objects can talk about themselves by their addresses. Like anytime you want to come by and see 323 St. Mary's, there it is. That's my address. Or what room are we in? I don't even know. White Gravener 201B. Yeah. So that would be our this pointer for all of us right now. Everybody sort of see this? All right, let's fix one thing that's actually really annoying to me that we haven't fixed yet. And what I'm getting annoyed about is every time we make a new node, we have to like set the data. So here's what I would like to do. I would like to create a new constructor. And what I would like this constructor to do is to take an integer value. So when we create a new node, we get the value in there. Okay. Okay, so I just created a new file. All I've done is I've created a new constructor. How do we know that this is a constructor? It has the same name as the class. What is this right here? A constructor that is a default constructor that doesn't have any values. What is this right here? Another constructor that allows us to specify things. So now what we can do down here is we can do this, node 12, and get rid of that. And now what's going to happen is we'll create a brand new node. And when we create that node, it will automatically be 12. And we can print it out. So let's just make sure that works. Expected a type, huh? No, I don't think I did. I've done this wrong. Hang on, let me look at my notes really fast. Oh, just around the 12. Did I put the parentheses in the wrong place? Oh yeah, I did. Sorry, that's wrong. Thank you. New node 12. That should work. Okay, and when we run this, we are still getting 12, which is what we wanted. So we're happy, right? Yes? All right. Why don't we take like a 1-minute break, and when we come back, we're going to do something a little bit different. Where? Here?
Oh, you did.
I did, yeah. Let's stand up. Come on. Use your break wisely. Don't just sit there in silence. Stretch. Get your blood flowing so you can learn more. So I can be mean to you. All right, welcome back. I can tell you have much more energy now. Congratulations. So now we're going to do some stuff with this node class with the added thing in there, okay? And in main, I'm just going to start creating some nodes and we'll mess around with them and see what's going on. So let's say we have node 1 and we have node 2. Okay. When we run this code, what is this line going to do? What's its name? Which constructor does it use? When we run this code, what's going to happen? It'll create a new node. What's its name? What value does it have in it? All right, let's prove that it's actually working the way that we want it to work. And the way we're going to do this is, and this is entirely for demonstration purposes only. You don't ever need to do this in your own code. How's that? So we can use the default constructor, or we can use, we'll call this one the value constructor, okay? So when we run this now, we should see a couple of little things of output that tell us which constructor is being used. Using default constructor, using value constructor. Everybody with me on that? Yeah? No? But, you know, there's more to computer science than this individual project. So sometimes I teach you things outside the project that you need. And I expect you to learn them anyway. So that's fair, right? What was that? Oh, okay, good. So I'm glad you agree. Okay. So we have these constructors and we can see them operating. If we have a constructor, what else can we have? A destructor. And we haven't really talked about destructors yet, but they exist. And do you know what they look like? What? If you're going to make cracky jokes, you have to speak up so I can hear you. Monitors? All right, this is a destructor. The destructor is the same name as the class, except it has the tilde in front of it. You can find the tilde on the upper left corner of your keyboard if you're using an American English keyboard. If you're using a foreign keyboard, you're entirely on your own. I have no idea where the tilde is, okay? But this is the destructor. And we can write a destructor. In this case, what do we really need our constructor to do? The answer is nothing. But we'll just output a friendly little message. Ah. Okay. All right. And we'll change this a little so we can see which node we're actually making. Okay. For the record, let me ask you a question. Do you have to put printout statements, cout statements in your constructors and destructors? Do you have to put printout statements or cout statements in your destructors and constructors? Do you have to put output statements in your constructors and deconstructors? You do not, okay? This is entirely for a classroom example. Now that I've said that, what's going to happen is like half of you will have it in your project, okay? You don't have to. It will, pardon? You're gonna make things crash if you do it. You're gonna make the autograder crash if you do. So don't. This is entirely for educational purposes only. Okay, so we can kind of see what's going on. All right, so we added some stuff here. You're confused what's going on? That's good. I'm going to teach you what's going on. So here's what's going on. Here's our code. Our code is really simple. All it does is it creates one node named 1 that uses which constructor? And it creates a node named 2 which uses what? Value 2. And then the program terminates. It doesn't even print out anything from main. But what I want to show you is that when this node 1 is constructed, it has a constructor that runs, right? We knew that all along. Node 2, when it runs, has a constructor that gets constructed. We knew that all along. And we can actually see this using the default constructor to make a 0 node, using a value constructor to make a 2 node. What we haven't seen before is the fact that the destructor comes along. Okay? And when these variables go out of scope because the function they're in is ending, and in this case it's the main function, the destructor gets called automatically. And you can see we have just a printout message in our destructor that says goodbye. Okay? Right? Everybody good with that? Yeah? Yes. I'm not sure it's a lie. I was trying to figure out if there's any situation where you needed like more than one destructor. I'm pretty sure I can't think of any off the top of my head. I think there's only one destructor per class. Because it's something that happens sort of in the background without you seeing it. Okay? Yep. I know. You don't. I agree with you on that. But do you see it exists? Great. Uh-huh. They run, the constructor happens anytime you create one of those objects. The destructor happens anytime one of those objects goes away. Now the question you had is like, why is the destructor running, right? The destructor is running because if we look at our code, node 1 and node 2 only exist inside this set of brackets. So at some point when the code gets down to this bracket and it goes, oh, I'm leaving the function. As I leave, I need to clean up everything that's in here. It will destroy those two things. Okay? You with me? Everybody with me still? Yeah?
But if you don't define the destructor in the class declaration, then it'll just do it.
There's a default one that's built for you. But what I'm going to try and convince you of is that the default one doesn't always work the way you want it to. Okay? Doesn't always work the way you want it to. So let's try this. What is this? The address of a new node. What value is going to be in there? 17. Okay. All right. So let's see what happens when we run this. Great, we make a 0 node, a 2 node, a 17 node, and then we destroy a 2 node and a 0 node. Uh-oh. Does something seem off to you about this? All right, because it doesn't have a name. In here, what ends up happening is node 1 gets destroyed and node 2 gets destroyed and node pointer dog gets destroyed. But what happens to this node over here? It does not get destroyed. It will hang out there forever until the program goes away, which it's doing anyway. But in a big program where you have things that are coming and going, things that are declared using new do not get automatically destroyed. They do not get automatically destroyed. And did I just prove that to you? Right? You can see the thing that has a 0 gets destroyed, the thing that has a 2 gets destroyed, right down there. Does the thing that has a 17 get destroyed? It does not. It does not. So one of the things that we need to learn to do is, as we're working with things like linked lists and some of the more advanced things that you will eventually learn about, is we have to learn to clean up after ourselves. If we have a new, we must have a yeah, no, yes. If we have something that creates nodes, we must have something that, that's right. And so the thing that destroys nodes is called delete. And delete takes a pointer to a node. All right, if you don't want to delete the dog, are you okay with cockroaches? Okay, we can name the variable anything you like. So, all right, so we're going to create a new node. I don't even like that. I don't know why I use dog. How about nameless? We're deleting it. We're not killing it. That's why you don't name things. Yep. Absolutely. Yep. Yep. Want to try it? Yeah, we already built the overloaded constructor, so we should not run into any problem. It should just print out 17 right there. Okay, so now we're getting a little bit weirder, because look what's happening now is you're seeing goodbye from the node that has value 17 twice. Because here's what's happening, and this is more complicated than I hoped to get into today, but I will just show you very quickly. When you call cout star nameless, it actually calls this friend function up here. And what happens is there's a copy of this node that's put into here, and then this gets destroyed when it goes out of scope. So what you're seeing is you're seeing these things getting destroyed that are actually copies. And in fact, there's 2 copies that get destroyed. One copy is the parameter that it makes a copy to send over here, and then the copy that gets put into the parameter. So it happens twice. But for today, though, let's get rid of that, because that's just more confusion. And I hear you rustling and you want to go to your next class. I'm upset. I don't know why you don't want to stay here all day. But we can see that when we run things, right, now that we have the delete, this thing 17 is getting destroyed. Okay, yep. Good question. Well, it'll be our cliffhanger for next class. Why do you need to destroy them? Have a good weekend. 2 classes to go. All fun stuff left. So, none of which is in the project, but all of it's on the exam.